Coming up, we repair a charge controller in inverter, then face the facts. One of our 2 low-budget products has to go. In the previous video we made some awesome bus bars, fully charged the batteries, then due to an unforeseen circumstance, the charge controller and inverter were both damaged. I've come across this fault before with these charge controllers. If you disconnect a battery terminal and pull too much current through them, they'll burn a track much like a fuse. In this case it wasn't drawing too much current, it was being killed by overvoltage. More on that in a bit. These should actually have a fuse in that position. I'm not going to go down that path, I'm just soldering a wire on this burned track and moving on. At least now it shouldn't burn out so easily. Any high currents will be passed on to the next components. We can worry about that when we come to it. A few of these look dry, no doubt they've been exposed to a lot of heat. Just checking a few other components in that area, and they all look okay. Let's give it a test before reassembly. It's good to go. Before we move on to the inverter repair, let's go over the cause of this problem. Fault finding, I discovered that with the charge controller disconnected and inverter turned off, the battery itself was putting out a whopping 36 volts. Instead of a maximum of 14.7 volts. This happened when it was fully charged, but why? My theory is this particular battery's cutoff voltage is slightly lower than the charge controllers, and 36 volts is somehow overcharge protection. Honestly, I don't know. I'm sure other batteries are not like this. No wonder they were so cheap. Back to the inverter repair. The inverter failed following the charge controller. I heard an audible pop and could smell smoke. Again, with this being an overvoltage failure, we know exactly where to start looking. Let's have a closer look. Clearly we can see there are 2 destroyed components. R9, which I assume is identical to R10, but is orientated the other way. In a 5-band, that color code is 20 ohm at 1% tolerance. Okay, let's order that 20 ohm resistor from AliExpress. Next we have the SSF 6005. I wasn't able to find one of these anywhere, let alone an uprated sibling, so I've substituted it with an IRF B3077. I ordered that one plus a few spares from eBay via China.
Many months later.
Actually, it's about 1 month later that both of the replacement parts arrived. I've recently moved my workshop and still can't find everything. My desolder wick is missing, so I'm removing the MOSFET without it. Here's our MOSFET, and its a replacement. I found a scrap of used desolder wick. Let's get that resistor out. Believe me when I tell you this took ages. one MOSFET in. Now about that resistor. I misread the color code and ordered a 2 ohm instead of a 20 ohm. What did I receive? A 20 ohm. How is that even possible? I've also ordered a half watt instead of a quarter watt. Might as well make it all a bit sturdy. And we're done. I carefully checked the connections, then gave it a really good clean. Now for reassembly. I'm not going to test it first, but I'll run it with the lid off so I can keep an eye on what's happening. Some fresh thermal paste. Now we've got all these brackets to put back. Just firing it up before I mount it on the wall. Nothing went bang, that's always a good sign. One oddity with this is the amps display doesn't seem to show anything. I've got a refrigerator plugged into it and it's running. I touched up a few cold solder joints on the SPWM driver board while I was in there, but it hasn't made any difference. Now let's get it mounted. Here we are a few months later, still going strong, so my repair has held up. So which one has to go? I believe the MPT7210A, while it has a lot of advantages over other charge controllers, it's not quite up to scratch. Tune in for the next installment when we upgrade it to something much more suitable and then do a cost breakdown for the whole setup so far. Thanks for watching.